Hey guys, welcome to Deep Dive Coding. Today we solve the LeetCode problem of the day, that is find the most frequent vowel and consonant. This is the easy question, most easy question you can say. And the problem is says that we are given a string S, and that is consists of the A to Z letter, and that is means lowercase English alphabet, and we have to return the maximum number of, we have to calculate the maximum frequency among the vowel and maximum frequency among the consonant, and their we have to return their sum. So this is the very easy question. If the vowel or the consonant is not present, then we can consider that frequency as zero, as question is given. So we can directly jump into the code. Before jump into the code, we can write the few steps I written over here. Let's say first we calculate the frequency of each element, so we have to store that frequency. So we take a map for storing the frequency, and we can, for the effect, as we know that the English alphabet is 26 number of English alphabets, so we take the vector of int, that is of, you can still name as frequency, and that space takes the 26, and we are each characters right now is 0. That means we are simply add, let's say, at the 0th index, you can say that at the, you can understand this way, that you can, at the 0th index at A, and one index element is B. That way we are calculating at the 25th index, we are count the frequency of the Z. Now after defining the frequency array, we are iterating over the uh, each characters of the S. I iterate over the each character of string S. And before going to further, like you at the end of the video, you will able to learn how to solve this problem optimally. Now go through each characters of it, that you can say that character ch of S, and you increase that count in the frequency array. So that will be frequency of S, not S, that is ch, that is the characters, and minus a, you remove the ASCII character, ASCII value from ch, so that you can get the index of that that alphabet, that is 0 1 2 up to 25, and you increase that count. After these things done, we are taking the value, that is, let's say, vowel frequency, that will store the maximum vowel frequency, and C frequency, that will take the maximum consonant frequency, and again iterate over the each value, that you can only iterate over the I equal to 0, I less than 25, and I plus plus, not 25, it will go up to 25, but less than equal to 26. Yeah, after this thing done, now we check that is this vowel index, is vowel index, I will pass through simply I, and if it is vowel index, then we track the count of maximum frequency of that vowel, that is maximum of V frequency, and current right now, that is frequency of I. And if it is not vowel, that means it's consonant, then we simply track the S frequency, C frequency, that will be maximum of C frequency, consonant frequency, and frequency of I. Now V frequency and C frequency stores the maximum frequency of vowel and consonant respectively, and we simply return the count, sum of the count, that is V frequency plus C frequency. And over here I defined the each vowel index. It will take simply the index and return the boolean value, and these are the vowels in the English alphabet in the lowercase a, I, o, u, and it will simply check that whether in index and vowel of 0, that means a, minus a, that will also be 0. So is this the vowel index is equal to the index, then it will return the true. So if these functions will return true if that is the vowel index. So over here we only calculate the vowel index. Now I think it's fine. Now let's try to run for the sample. Yeah, it's run for the sample test case, and now let's discuss over the time complexity. So it will simply iterate over, it will take create the space of 26, So it will take over a maximum of big of 26, and this will iterate over the string, so it will take s dot length, string dot length, and again it will iterate over the big of 26, that is 26 times. And you can say that, yeah, these are the, so total time complexity would be big of 26 plus s dot length, and again 26. So you can say that this will go up to s dot length, because s dot length is quite high, that as compared to the 26, so that is the constant. So s dot length as go higher, that will be increase the time complexity. And you can say that space complexity, we are taking the frequency array, that will take the space of 26, so it will take 26, and apart from that we are not taking any extra space. So big of 26, that you can say that this is big of 1 space complexity. Now let's try to submit this code. And if you guys found anything in helpful, please write in the comment box. And thank you guys, thank you for watching. Stay tuned for the more